Let's review the other 4 methods here that are available to us that we're quizzed on. Oh boy, yeah, that quiz. All right, Cece, roll with 1. Side, side, side. Perfect. Next way, Savannah. Side, angle, side if the angle's in between. How about another method here? Choom. Kai, how about another one? Angle, side, angle. Don't be so thrilled. Next one up, final method up here. Robert. Angle, angle, side. And then the quiz. I thought I was loud enough, theatrical enough, intense enough, but we still had people put angle, angle, angle. We still have people put angle, angle, angle as a way of proving triangles congruent. And guys, it's never going to be a way. All right, everybody good? I don't know what, other than getting on, maybe doing a cartwheel up here, which will never happen. All right, unless you want somebody new to come in here and teach this course, because I'll be out of commission. Angle, angle, angle is never going to be a way. Okay, so please get that out of your mind. Next up, right triangle. Review the vocab, the parts of the right triangle. This side right here, which is always located across from the right angle, that's known as your hypotenuse. Yes, because that word's going to come up today. And then the other 2 sides that make up the right angle, those are the legs. Good. I want you to be familiar where they are, because you're going to need to know where they are for this 5th method. Questions on hypotenuse or where the legs are. All right, so this 5th and final method has nothing to do with A's and S's. It actually has 2 different letters, and that is H, L, the 5th and final method. The H stands for hypotenuse, and the L stands for leg. Hypotenuse, leg. Hypotenuse, leg. First piece of info I want to make very, very clear. You cannot have a hypotenuse unless you have what type of triangle? So guess what? Nobody's using this method unless you have what type of triangle? Oh, darn right, a right triangle. If it's not a right triangle, you got 4 to worry about. All right? This method can only be used in right triangles. Now, I do not want you to get in this habit. Right triangle, HL. Right triangle, HL. That's not how that works. Watch. I put that on your quiz Friday. You're going to say, yes, they are congruent. By what method? Okay, so HL does not equal, right triangles does not equal HL. Okay, do not get that in your mind. What does HL look like? All right, I do need right triangles. You're going to need this. What did I just mark congruent? Ooh, hypotenuses, hypoteni. We'll go with hypoteni. All right, mark the hypoteni and a pair of, what are those I just marked? Legs. Why isn't that side angle side? 2 sides of an angle. Why isn't that one side angle side up there? Why wouldn't I say? Because if I put that on Friday's quiz, everyone was writing not possible. Why wouldn't you put side angle side? What's wrong with side angle side here? Shoo, where am I going with that? I'll get there. Ahmed, why isn't this side angle side?
Those angles are not between all sides.
There you go. My right angles are not in between. But does everybody see now? H, L, this new method. Everyone good now? Got to be in a right triangle. Got to have the hypoteni and a pair of legs. All good before we start a proof with it. All right, let's hop into a proof and see why it's HL. I'm going to do this proof a little differently than in the past. I want to mark the diagram with you instead of letting you go on your own. ABC, DCB, those bad boys are right angles. Mark them. AC, congruent to DB. What are you now marking on the diagram right now? Yes, a pair of sides, but also the what of the right triangles? The hypoteni. So I had the hypoteni at least. And a pair of sides. Something is not marked that I'm not doing for you. That still stays consistent. What else could you mark on this diagram that I have not marked and will never mark for you? Choom, what other markings? Thora, can I put up here? Shared side, CB. So without knowing anything about HL, does everyone see why it's not side angle side? Let me cover one of them up for you. Is that right angle in the middle? So don't say side angle side. But what do I do have? I have the hypoteni given. And then what did you guys, what's the shared side now? That's the what of the right triangle? Leg. Everyone see HL. Everyone see the H and the L working here and not side angle side. All right? Be careful. Proof is a lot different now too. The proof is going to look a little bit different. Go ahead, just write. I'll blow my blood pressure is going to go through the roof. Go ahead, mark your shared side. Mark your shared side. Go ahead. As this went down again, same place as it did fifth period. I will find a way to toss this thing through the window before the year's end, without a doubt. Don't try to get ahead of me either. Just write your shared side in, because you think you know what you're doing and you're going to be missing a few steps. All right, let me catch up. Given BC congruent to BC, reflexive. All right, I'll stop there. All right, we all agreed it was HL when we marked our diagram. Are the hypoteni congruent in your statements? Are the hypoteni congruent? Yes, no? Yes, it was given. Are a pair of legs congruent in your statements? Yes, we just wrote that down. We're not done yet, though. You can't say the triangles are congruent yet. Here's why. HL is reserved for what type of triangles? So darn it, you better have right triangles in your statements. Okay? If you want to use HL, you need what type of triangle? A right triangle, so you better state that you have right triangles. That's what's got to come next before saying they're congruent. In any HL proof, you need to state the right triangle in their names. Triangle, ABC, and triangle, DCB, are right triangles. All right, ready for a new, it's not, I know, it's going to make sense when we write it. How do we know they're right triangles? I'm not trying anything complex, just tell me why. How do we know these are two right triangles? Macy? No, it says they're right angles in the givens. How do I know they're right triangles? You're overthinking it. Why is this bad boy a right triangle? It has a what in it? Which stands for a?
Right triangle or right angle?
It has a right angle, yes. It's a right triangle because it has a right angle. Right triangles have right angles. Okay, it's a slightly new reason. Deal with it. Do you have the hypoteni? Let's go through my checklist again for HL. Do you have hypoteni congruent? Given. Do you have a leg congruent? Reflexive. Did you tell me you're working with right triangles? Because that's the only time HL can be used. Yes. So now we can say triangle ABC congruent to triangle DCB with our fifth and final method, HL. Do not move on to the next proof. Nobody wants to ask any questions? I would certainly have a question. Because there's something I did not have you write down that we've been writing down in many of these proofs so far. Kai, what's the problem here? I brainwashed you to do what?
We never put the right angles congruent.
Why didn't I never say the right angles were congruent? Did I forget? Nope. Here's why I did not have you write the right angles were congruent. The H in HL, is that a side or an angle? Side. The L in HL, is that a side or an angle? So when you use this method, do you need any angles congruent? No, you just need sides. So that's why in an HL proof only, you do not have to write the right angles are congruent. But I understand all last week I brainwashed all of you to say, you tell me they're right angles, and the next step you tell me they're congruent. So if you still do that, that's fine. But everyone realize that now. If you tell me right angles are still congruent, you're not getting any points off. It's just an extra step that was not needed in this HL proof. So if you want to keep writing it down, because brain and hand do it all work as one, go ahead and do it. All right? Honestly, for some of you in here, I do it anyway. All right? I wouldn't have put you in the position where, do I do it? Do I not? Do I do it? Do I not? Some of you, I don't know if you can handle that. All right? So just put them there congruent every time. But in an HL proof, you do not need to tell me the right angles are congruent. Okay, any questions on that first HL proof? You need hypoteni and you need legs. All right, one doesn't make you great. What's up next? All right, go ahead and mark your diagram, and then we'll talk. Oh boy. I wrote the givens in. You're welcome. All right, let's discuss before we just start writing down some random stuff and not knowing where it's going. Everyone take a look at. Have you been able to read that proof statement? 1 congruent to 2? Yeah. We did that. I didn't quiz you on it, but we did talk about it the day before the quiz. Angle 1 and angle 2 will not be congruent until I have what congruent first? The triangles they're contained in. Right? Because they are corresponding parts. I don't want to give away the abbreviation because I'm going to ask somebody at the end. But those are corresponding parts, and they're not congruent unless the triangles are congruent. So that's your first job. Everyone sees the 2 triangles where 1 and 2 are contained. Let's get them congruent. Let's get these 2 congruent to each other somehow. All right, let's go through what I had given. Perpendicular lines. So we should have our right angle symbols in there. BF and DE. Oh, some of us got nabbed on this on the quiz. Are BF and DE sides of those triangles I just highlighted? Are they sides? No, they're much longer than the sides in the triangle. Some of you on the quiz counted them as sides. You can't. You can't count those as sides because my side here is BF and my side is BE and I'm giving you BF. That's longer than what I need. You can't count it as a side. We all good there? Because I know we fell in that trap on the quiz. So I can't count that as a side. We'll get back to it. AB, congruent to CD. Can I count those as a pair of sides? Yes, those are actual sides. So let's go back to the BF and DE, the ones I can't count as sides. How are we going to make them into sides? I can count. I got BF and ED congruent to each other. How am I going to make those into sides? I actually can count as a side. Let me put it this way. They're longer than what I need. I need to make them smaller. I need to make them shorter. I need to make them smaller. How am I going to be able to do that? Something you already know how to do here. Savannah, how am I going to make them smaller? Subtraction. So it's going to be subtraction to eventually get, I'm not ready to write a darn thing down, to get BE congruent to FD. All right, everyone look, because we got to make a decision here. I see 2 sides and an angle. Is the right angle in between those 2 sides? Is the right angle in between those 2 sides in one of the triangles? In between or not? No, so it's not side angle side. It is a right triangle. What are A, B, and CD in those right triangles? Those are the hypoteni. And then once we do Savannah's subtraction, what's BE and FD going to be? Those are going to be my 2 legs. Oh, so this is going to be HL. Right angle's not in between, so it's not side angle side, but everyone see where the H and the L are going to come from eventually. This is all in my head. It's got to go in the paper here in a second. All good? Okay, let's do the subtraction part first. Oh, I don't know if anybody. I'm not ready to write subtraction in step 2. I'm not ready to write subtraction because you need how many pairs to subtract from each other? 2. I've only circled the 1 pair up there. Sorry, can't subtract yet. You better find what you're subtracting from them so I can write that down first. Because you need both pairs, whatever you're subtracting, both pairs need to be congruent. And I only have 1 pair up there. So what do you subtract from each of these to get to BE and FD? What's got to be subtracted from both there? Where am I going? Ahmed? EF, there you go. Yep. From both of them. So I got to say EF is congruent to itself. I do get a little nervous at this point in the year because some kids, isn't reflexive just for shared sides? No. It can be used differently in subtraction and addition. All right, that's where you got to get up to that level now. Get up to that level. All right, now that I have 2 pairs of equal parts, now we can subtract. What pair? Give me 2 pairs to subtract first. Going deep, Jason. What do you want me to subtract? BF minus EF is the same as if I subtracted what other pairs up there? Going Zane.
DE and EF.
DE minus EF. Got it? Subtraction. I promised you this back in Unit 2. My promise still holds true. And it will all year. Anytime you add or subtract, next step's going to be substitution. What are we using substitution for? To say what 2 segments are equal now. Ahmed, which 2 segments by substitution?
BE and EF.
EF?
DF.
DF, that's what I thought you said. Relax with the attitude. Good. BE and DF. Quick check. Do I have the hypotenuse congruent? I got the H down. Do I have a leg congruent? Okay, I got the L down. But this is only used when? In right triangles. I don't see any listed. Oh, whoa! What do you need to have right triangles? Not there either. I gave you it in the last proof. It's not written here, though. It's not given in this one. So everybody see. To use HL, you need right triangles. To have right triangles, you need right angles. We got a long way to go here. First up, tell me you have right angles. Name them. Name those right angles here. Anderson, where are they? Angle? AEB, yes, and?
CFD.
Angle CFD. This isn't anything new. Why are they right angles? Why are those bad boys right angles up there, Shreya?
Perpendicular lines.
Thank you. Perpendicular lines form right angles. Now look, if mind and hand just writes they're congruent, all right angles are congruent, fine. That's fine, guys. Remember, that's fine. It's not a big deal if you have an extra step in there. I'm not going to say they're congruent because I know this is an HL proof. But now that I have right angles, can I tell you that? Now you can tell me you have right triangles. So triangle AEB and triangle CFD are right triangles. How do we know they're right triangles? Let's do this one more time. How do I know they're right triangles? Shreya?
HL.
That's a method of proving them congruent. I'm just asking why they're right triangles. How do we know they're right triangles?
Right triangles have right angles.
There we go. Whew. I got the H. I got the L. I now have right triangles. Now I have congruent right triangles. And unfortunately, we can't just copy it from the proof statement, huh? So now we got to make sure order matters. Name one of the triangles to start this process off, Anderson. Triangle. ABE, sure. Congruent to. All right, Anderson's putting you guys on the spot. He said ABE, so better name the second one correctly, matching up the corresponding sides and angles. If I go ABE, okay, I got the next one. ABE matches up with, finish off, Molly. CDF, thank you. Quick note, this is the only thing that needs to be in the correct order. I don't care how you tell me the right triangles, what order you do that in. I don't care about the right angles. This is the only thing that needs to be in corresponding order. And that is HL. Bless you. And now any of the parts are congruent, including angle 1 congruent to angle 2. Whoo, better get more practice at this. I really don't want to write out the full meaning. I'd rather just write the 5-letter abbreviation, Evan. That looks good to me. And can we also? 8 steps. 8 steps. Wow. You've grown up so quick. Grown up so quick, kids. I can't believe it. 8 steps. Remember the 2-step days? Wish we could go back to them, huh? 8 steps. Wow. Just so quickly you've grown up. All right, here we go. Final one. And, it's that time of the day. What class are we in? Honors, yes. We did not do this proof with my AD kids. All right, this is at a different level right now. Just look at the darn proof statement. Whoa! Look at that proof statement. Never have seen that before. We've proven things congruent, but never things bisecting. Oh boy, this is going to be fun. BD congruent to BC. Hey, pay attention here. Watch where those perpendicular lines are. Everyone assumes by looking at the diagram that the right angles are in a certain spot. They're actually not. Look where BC and AD meet, or BD and AD meet. And look where BC and AC meet. Those are your right angles. All right, forget about the triangles. Let's look at the proof statement. You need to show me that BD bisects DAC. Well, let's say it does. It does bisect. What 2 angles up here have to be congruent then? If AB is indeed bisecting DAC, that must mean these 2 angles are congruent to each other then. All right, if AB is a bisector, what 2 angles have to be congruent then, Evan?
DA and BAC.
Show me then. If you show me that's true, those 2 angles Evan just gave me, then it's got to be a bisector, right? Everyone agrees? If you can watch, this is not true, so don't mark it. If you can show me that's true, okay, it bisects. Bisects. How's that going to be true? If the one are congruent first. Yeah, it's always you got to prove the triangle's congruent before you prove any of its parts congruent. So that's our goal right now. Prove the triangles to get Evan's angles to get to the proof statement. All right, I have a pair of sides. Looks like I have a pair of sides. Anything else you're marking on your own? Because I don't. I'm not marking it. CC?
Oh, the shared side.
Yep, AB, shared side. All right, everyone take a peek at what you marked. Is that side angle side? Side angle side? Nope. Okay, well, hold on. What's AB acting as in those right triangles? That's the hypotenuse. And how about DB and BC? That's the? Okay, we all clear. We got HL on our hands. Okay, we got an HL. Not because it's HL day, but because I have the hypotenuse and the leg. The only thing I didn't write down was that the hypotenuse was congruent. I have the L right here, BD and BC. We did not write down that the hypotenuse, AB, congruent to itself. Reflexive. Remember, this is special proofs. When you use HL, it requires some special statements. HL can only be used in what type of triangles, Liam?
Right triangle.
Okay, well, I don't have that stated that I have right triangles. Before you have right triangles, you need to have what to have a right triangle? Where am I going? Shreya, what do right triangles have? And I don't even have that. I don't even have that written down, so that's where I'm going to start. Name the two right angles for me. Shoom, Aisha, name the two right angles. Angle. Good. BCA and BDA are right triangles, or right angles, excuse me. How do you know they're right angles? Shoom, keep going across here. Macy, why are those right angles? Guys, again, if you right now you're writing down that those right angles are congruent, keep writing it down. It's fine. Keep writing it down. If I have right angles, now I have right triangles. BCA and triangle BDA are right triangles. Again, for a third time, because I'm still not comfortable. Zuki, how do I know they're right triangles? That they do. And so should you in your statements. You should have right angles in your statements. Got the H, got the L, got the right triangles. Now tell me they're congruent. Name one of them any way you want, because we do have to match them up here. Yuzuki, going back to you. Triangle. Good, look at that. We go BCA. What are you naming the other triangle with if we go BCA? Zane?
BDA.
All right. Question or answer?
BDA.
Thank you. Hey, Joe. Why did the triangles need to be proven congruent? What are we trying to prove? What parts are we trying to prove congruent? If the triangles are now congruent here, going deep there. Lavanya. There's a specific pair. Oh, can't look at somebody else's here. Come on now. Come on. Too harsh, I know. Deal with it. What parts are we trying to prove congruent? So we show AB bisects DAC. Yeah, and why are those two going to be congruent now? We don't have a bisector. We're trying to prove it. We just proved the two triangles congruent. So why are those two angles in particular? There we go. CPCTC. Angle DAB congruent to angle BAC, CPCTC. And now they're congruent. So what's AB have to be? Now these angles are congruent now. Now AB has to be a bisector of DAC. AB bisects angle DAC. Nothing fancy here. How do I know it bisects? Definition of a bisector, yeah. Cuts it into two equal parts, which we showed in step 6.